Hi everyone. So yesterday we checked out kind of an introduction to trig, and we started to try to approach trig from some of the things we already knew. We dealt with the Pythagorean theorem, we dealt with similar triangles, and then we dealt with this notion of what we called the tangent ratio. And the tangent ratio was for any given angle, it was the ratio of the side opposite that angle divided by the side adjacent to that angle. And one of the things we discovered yesterday was for the same angle, that ratio will always be the same. Because no matter how big or how small that triangle is, if there's always that 75-degree angle there, for example, that was the example we used yesterday. If there's always that 75-degree angle, then the side opposite the 75-degree angle divided by the side adjacent to the 75-degree angle always has to equal the same thing. Okay, now that only works if one of those angles is 90 degrees. Okay, it has to be a right triangle in order for those ratios to always be the same thing. All right, so today what we're going to do is really start diving into, well, what can we do with this knowledge? What can we do with these ratios? And we're going to take a look at the trig ratios and try and solve for unknown lengths. So just a quick little bit of history for you. The study of trigonometry dates back to ancient Babylon, around 2000 BC, as scholars attempted to understand the motion of stars across the night sky. They conjectured that the stars lie on a great sphere about the Earth, and consequently assumed that their motions across the sky were along great circular arcs. The natural question to ask is, where on this circle might the star be if I'm viewing it at a particular angle x? And this began the study of what was called circle geometry. And that forms the basis of all of our trig, okay? So yesterday we were introduced to the tangent ratio, which was the ratio formed by taking the opposite side of a triangle and dividing it by the adjacent side. In fact, there are 6 different ways. There are 6 different pairs that I could look at, okay? Think of it now, if I did opposite over adjacent, I could have also done adjacent over opposite. Okay, so that's 2 now. I want you to try and figure out if you can find all 6 ways I could pair up 2 sides. All right, so these are them. I could do opposite over adjacent. Now that's what we talked about yesterday. That was the tangent ratio. I could do hypotenuse over adjacent, or I could do adjacent over opposite, or I could do hypotenuse over opposite, or I could do opposite over hypotenuse, or I could do adjacent over hypotenuse. So those are the only 6 ways I can pair 2 of these guys together. Okay, now we're going to make it even easier on you in grade 10. We're only going to actually deal with 3 of them, and they are called the 3 primary trigonometric ratios, and these are them. Okay, so the opposite over adjacent we talked about yesterday, and that's the tangent ratio. And the tangent ratio is your TAN button on your calculator. Opposite over hypotenuse, that's called the sine ratio. I know that looks like the word sin there, but sine is actually S-I-N-E, and then this is the 3-letter abbreviation of it. And then for adjacent over hypotenuse, that's your cosine ratio, which would be spelled C-O-S-I-N-E, okay? And then the 3-letter abbreviation is C-O-S. So on your calculator, grab your calculator and take a look. Yesterday you found where the tangent button was. You saw that button that said T-A-N. Right beside it, you'll see the S-I-N button and the C-O-S button, okay? All right, and these are called the primary trigonometric ratios. Okay, no matter how, or no matter what the trig question is, we always solve it the same way. And this is why trig, kids really like trig, because it's very repetitive. Once you understand what you're doing, you set things up always, always, always the same way, okay? So the first thing you do is you need to decide the ratio, and that's based on what you have and what you need, okay? So now most of you should have formula sheets, and this actually is on your formula sheet, so you don't have to memorize these guys, but lots of kids find this little acronym helpful, SOHCAHTOA, okay? And what that means is it's just a little acronym to say your sine is opposite over hypotenuse, your cosine is adjacent over hypotenuse, and your tangent is opposite over adjacent. Okay, so for the first couple of examples here, I'll leave that on the board just so that you can think about, hey, this is how I try and figure out whether I'm going to use the tangent ratio or whether I'm going to use the sine ratio or whether I'm going to use the cosine ratio. Then you set up your equation, and your equation is always set up like this. It's always tan of the angle. Now, just for clarification, it doesn't have to be tan, right? It could be sine or it could be cosine. But you always start with that trigonometric ratio. So tan of the angle equals whatever that ratio is. So for tan, it's opposite over adjacent, okay? You always start a question. The very first line of your question should always look something like that, okay? So I just need to get this ink off for you, sorry. Okay, so this example uses the tangent ratio, but you would set things up the same for the other two. Then you algebraically determine your unknown and make sure, so important, make sure your conclusion has the proper units in it, okay? I will dock you half a mark if you don't have the proper units. Okay, so let's play. Sorry, I didn't actually mean for that to appear yet, so I'm going to make it go away for a sec. So here's what I want you to think of. Very first thing, label opposite, adjacent, and hypotenuse. So we're looking at this 70-degree angle right now. So this is my opposite, this is my hypotenuse, this is my adjacent, okay? That's the first thing you should always do in all of your questions. Now, walk yourself through this conversation. I want to switch colors for a sec. I have my adjacent. I know it's 5. I need my opposite. So I want the trigonometric function that pairs opposite and adjacent together. So who uses opposite and adjacent at the same time? It's tan. Tan is opposite over adjacent. So for this question, I'm going to solve it using tan. Okay, so I set myself up like I had there and then hid on you. Tan of 70 degrees equals opposite over adjacent. Well, the opposite in this one is r, and the adjacent is 5. Okay, once I have this, it's just some algebra to get r all by itself. If I want r all by itself, I have to divide, or sorry, right now I am dividing r by 5. So to get rid of it, I multiply by 5. That will get r all by itself. I have to get rid of the 5. So r becomes 5 times the tan of 70. And you just type that in your calculator, okay? Literally, just in your calculator, go 5 tan 70. Make sure you're in degree mode. We talked about that yesterday. If you are a TI kid, you'll press mode and go down 3 over 1, so that degree is highlighted. If you're a Casio kid, you press shift menu and go down to the word angle and make sure you select degree. Okay, so you should be getting 13.7 when sorry, 13.7 when rounded to the nearest tenth of a centimeter. The other silly place kids lose marks in these questions is they don't follow the rounding instructions, okay? So if you're not properly rounded, I will dock you half a mark. And if you don't have your units, I will dock you half a mark. So be really careful of that. Okay, so find the missing length to the nearest tenth of a centimeter. So here we go again. This time I'm looking at the 42. I know that the 7.2 would be my opposite. This guy here is my hypotenuse, and this guy here is my adjacent. So I have my opposite. I want my adjacent. I'm looking for a trigonometric function that connects opposite and adjacent together at the same time. Again, that's your tangent ratio. So I'm going to set this up using tan again. So I say tan of 42 is opposite, which was 7.2 over z. Now this one's a little trickier to solve. It's not bad, but there's just an extra step here. The reason there's an extra step here is because my unknown is actually on the bottom of the fraction. So the first thing I want to do is actually just get rid of the fraction. Okay, so essentially I want to look at this and I want to say, okay, that z is being divided. I need to get rid of a division of z. How I get rid of a division of z is I multiply both sides by z. Okay, I'm doing the inverse operation to undo the thing I'm trying to undo. Now, all that actually does is it gets my z onto the other side. So now I'm looking at z times tan of 42 equals 7.2. I didn't isolate for z there. I just got rid of the fraction so that it was a little easier to look at. So now the goal is going to be, we need to isolate for the z. So what's happening between the z and the tan of 42? multiplication. So to get rid of it, we will divide. So z is going to equal 7.2 divided by the tan of 42. Now, I just type that in my calculator, and I end up with 8.0. Now, I'm pretty sure we had this conversation on the last lesson, but just for clarification, remember that 8.0 is important because you were asked to round to the nearest tenth. If you just write as an answer 8, that's not rounding to the nearest tenth, that's rounding to the nearest whole number, so just be careful of that. Okay, next guy, I'm looking at this 55 degrees here. Given that 55, this is my opposite and this is my hypotenuse. So I have my opposite, I need my hypotenuse. So now I'm looking and saying, okay, which guy connects opposite and hypotenuse together? And it's sine. So I'm going to set myself up the same way, except instead of using tan, I'm going to use sine. So sine of 55 degrees equals 7.6 over m. Opposite over hypotenuse. Opposite was 7.6, hypotenuse is m. Now, this is the same setup that I had last time. I need to get rid of my division of m, so I'm going to multiply both sides by m. Then I need to get rid of this multiplication of sine of 55 in order to isolate m. So I'll divide both sides by sine of 55, and then that's going to leave me with 9.3 centimeters. Okay? Okay, next guy, here's my unknown. So what's going on? Given that we have this 39 degrees here, this would be my opposite, this would be my hypotenuse, this would be my adjacent. So when I walk myself through this, I'm going to say, okay, I have the hypotenuse, I want the adjacent. So I need to find the trigonometric pair that will connect adjacent and hypotenuse together. That would be cosine. The a and the h are together on cosine. So I set myself up the exact same way. I'm going to say cosine of 39 degrees equals adjacent over hypotenuse. Adjacent is x, hypotenuse is 12. This one's the easier version because we just have to get rid of a division of 12 in order to isolate for x. So x will equal 12 times the cos of 39, and then that is 9.3 centimeters. Okay, now we'll take a look at this guy. I'm looking at this angle, so this is my opposite, this is my hypotenuse, this is my adjacent, okay? And so now I'm looking at what do I have and what do I need? I have the adjacent, I need the hypotenuse, so I'm looking for a trigonometric function that connects adjacent and hypotenuse together, and that would be cosine. So I set myself up, cosine of 55 degrees is adjacent, which is 17, over the hypotenuse, which is x. Now, I need to get rid of the division of x, so I multiply both sides by x. Then I need to get rid of the multiplication of cos of 55 in order to isolate x, in order to get x all by itself. So x ends up being 17 divided by the cosine of 55 degrees. I type that in my calculator, and I get 29.6 centimeters when properly rounded. Okay, again, I have the 35 degrees, so this is my opposite, this is my hypotenuse, this is my adjacent. Always figure that out first. Now take stock of what you got. I know what the hypotenuse is, I want to know what the opposite is, so I'm looking for the trigonometric ratio that connects opposite and hypotenuse at the same time, and that would be sine. So I go sine of 35 degrees is x over 5. I have to get rid of the division of 5 in order to get x all by itself. So I multiply both sides by 5, and 5 times the sine of 35 gives me 2.9. Okay, a playground, a straight slide in a playground makes an angle of 28 degrees with the ground. The slide covers a horizontal distance of 4.5 meters. To the nearest tenth, determine the length of the slide. You should always, if you are not given a picture, draw a picture first, okay? So I have a straight slide going down. I know the angle that it makes with the ground, and I know the horizontal distance it covers. So I'm looking at something like this, where this guy here is my slide. I was asked to determine the length of the slide, so that's why I put the X there. I know it covers a horizontal distance of 4.5, and I know it makes an angle with the ground of 28 degrees. Once I've established that, I'm right back to where I was on the previous slide. This is my 28 degrees. Oh, sorry. I probably shouldn't do that in green on green. This is my 28 degrees. So this is opposite. This is my hypotenuse. This is my adjacent. I need to look at what do I have and what do I need. I have the adjacent. I need the hypotenuse. I'm looking for I'm looking for the trigonometric function that connects adjacent and hypotenuse together, which is cosine. So I'm going to say cosine of 28 degrees is 4.5 over x. I have to multiply both sides by x to get rid of that division. Then I have to divide both sides by the cos of 28, and I just went right to that step. Okay, so then 4.5 divided by the cos of 28 gives me 5.1. Now, this was like an application question, so you should always conclude with some sort of a concluding sentence. So the slide is 5.1 meters in length. Okay, Sally places a ladder against the side of a house so that the top of the ladder makes an angle of 52 degrees with the side of the house. The base of the ladder is 1.2 meters from the house. How high off the ground does the top of the ladder reach to the nearest hundredth? So I gotta draw a picture first. You should pause me and draw your own. So here's my ladder. I know that I'm looking at 52 degrees with the house, right? So if it's leaning against the house right now, this, which I labeled as X for another question oh no, that's the question I'm doing right now. I labeled this guy as Y because I know there's another question coming up. So here's the house. So this would represent how high off the ground the ladder hits the house. The 52 degrees is with the house, so that's the ladder and the house. That's how that angle gets formed. And then I knew the 1.2 because it's at the base of the ladder, which would be over here, is 1.2 meters away from the house. So if I'm solving for X right now, I've got this guy and this guy that I'm dealing with. Well, 52 is right there. This guy would be my opposite. This guy would be my adjacent. So I'm going to need to use the tangent ratio for this guy. So I go tan of 52 is 1.2 over x. Now I'll divide both sides by x and multiply, not divide both sides by x. I need to get rid of the division of x. So I will multiply both sides by x and then divide both sides by the tan of 52. So 1.2 divided by the tan of 52 is 0.94 meters. Okay, so the ladder reaches 0.94 meters off the ground when it hits the house. Okay, so the next question is how long is the ladder, which is why I had stuck that y there. Now, some of you may say, okay, well, I could use the x that I just solved for and the 1.2 in order to solve for y. You could, but here's the problem with that. What if you were wrong with your x? What if you got that answer wrong? Okay, if you use a wrong answer in the next step and you didn't actually have to do that, you're wrong. You're hooped for the second answer because you're using a wrong answer in the second step. So whenever possible, I always want you to only use what was given to you. So what was given to you was the 52 degrees. This is opposite. This is my hypotenuse. Who connects opposite and hypotenuse together? Well, that would be the sine ratio. So we're going to solve this using sine. Sine of 52 degrees equals 1.2 over y. Now, I'll multiply both sides by y to get rid of that division and divide both sides by the sine of 52. So y will equal 1.2 over the sine of 52, and that is 1.52 meters. So the ladder is 1.52 meters long. All right. John is 1.75 meters tall. He stands away from the tree and uses a clinometer to measure the angle formed with his line of sight and the tree. By the way, a clinometer is just a measuring device for angles, okay? What you do is you look into it, and if you look at, say, the top of a building, it will measure the angle from your line of sight to the top of the building. Now, depending on whether you do like a store-bought clinometer or a makeshift, make-my-own clinometer, It may be giving you two different types of angles. One may be from the vertical and one may be from the horizontal. But doesn't matter. In a question, you don't have to know that. We will tell you exactly what angle you'd be looking for. Okay, so for this one, it says that we're looking, the clinometer is measuring the angle from the line of sight and the tree. Okay, so that would be up in that corner where the tree is to the line of sight. Always look for where those two lines connect, and that's the angle that they're talking about. So his clinometer reads 63 degrees. Calculate the full height of the tree. So there is one little extra piece in here that I don't know if you caught when reading the question yet, but I would love it if you just paused me for a second and see if you draw your own picture first. Okay, so the picture that I drew looks something like this at first, where, okay, here's Johnny's line of sight, I guess I should say, and here is that 63 degrees because the tree is here, okay? But what I want you to see is this here, if you can see my mouse, is not the full height of the tree, because we have to take into account the fact that John is 1.75 meters tall. So what I did was I said, okay, here's John's eyes, and that little piece here is 1.75. So we're going to use trig to find this piece here, but at the end of it, we'll have to add John's height, which is 1.75, in order to figure out the full height of the tree. Now, eyes are not directly on your top of your head, but we will assume, for the purposes of these types of questions, you can assume eyes are directly on top of the head, okay? All right, so we got tan of 63 equals 5 over x. The 5 is my opposite. I'm looking for adjacent, so tangent uses opposite over adjacent. I'm going to multiply both sides by x and then divide both sides by the tan of 63. And that's going to give me 5 over the tan of 63. And that gives me 2.54. Now that is the height from, if I can just get up there, that's the height from there to there, okay? Because that's the part of the triangle. So now I need to add in John's height. So I'm going to add in 1.75 and say that the total tree, now I follow rounding directions. Take note, I didn't round to one decimal place right away. You should never round to what they ask you to round for in the middle of a question. You should always wait until the final answer and write a bunch of decimals in the middle if you are using decimals, because you don't want to run into any rounding errors, okay? So the full height of the tree is 4.3 meters, okay? So hopefully this makes sense. Here is some work for you to get going on and to see how you're feeling about things. Give yourself the time to practice. Make sure you're clearly communicating. That's the other thing with trig, is sometimes we skip steps and then we're not really communicating well. Make sure you're clearly communicating so you'll get full value for each of the questions that you do. Okay? See you soon. Take care.